Good morning, everyone. Today we see about the IR spectroscopy, IR spectroscopy in the organic molecules and how it works in organic molecules. IR spectroscopy in organic chemistry identifies the functional groups by measuring the how molecules absorbs infrared light, causing a specific bond vibration, that is stretching and the bendings at characteristics frequencies which appear as a peak on the spectrum. These uh, peaks on the spectrum, it is we get wave number versus the transmittance. So stronger bonds and the lighter atoms vibrate at the higher wave numbers, allowing chemists to quickly detect the groups like the carbon oxygen attached with a double bond carbonyl, OH groups, carbon nitrogen triple bond, that is a cyanide group, and the etc. Adding in structure conformations and the purity checks. So this is how it works. So it works with the IR radiations and the vibrations. When the IR light hits the molecule, bond absorb energy and the vibrate, stretch, bend at the natural frequencies. Like the springs, dipole moment, or the vibration to be seen or the absorbs, it must cause a change in the molecule's dipole moment, uneven electron sharing. Spectrum generation, how this spectrum generation is generated according to the and the IR spectrometer plots percentage transmittance, how much light gets through versus wave number energy upon the frequency, that is centimeter inverse. Peaks, low transmittance show absorb frequencies while the rest of light passes through the material. So this what are the key regions of this IR spectrum? That is diagnostic functional group region. This diagnostic functional group region, it is above 1500 centimeter inverse. So these are all characteristic frequencies above the 1500 centimeter inverse. It is called as the diagnostics of the functional group regions because the maximum functional groups are present between these regions. So this which characteristic frequencies are the shows characteristic peaks for the functional groups, that is carbonyl. So this carbonyl is carbon attached with oxygen by the double bonds, hydroxyl. In hydroxyl, oxygen is attached with hydrogen with the single bonds. Amines, nitrogen is attached with the hydrogens with the single bonds. Then second, there is a fingerprint region. So the fingerprint region, it has a range below the 1500 centimeter inverse. It is a complex region unique to each molecule, useful for the confirmations identified by the matching to the known spectra. So there are the two key regions for this IR spectroscopy. Uh, in IR spectroscopy region, there is a diagnostic. Then second is the fingerprint regions. So the diagnostic, or it is also called as a functional group region. It is above the 1500 centimeter inverse, and the second is the fingerprint region. In the fingerprint region, it is below the 1500 centimeter inverse. So this is how this information, which type of information is given by this IR spectroscopy. So this functional group. So first is a functional group. So we get about the information about the various types of the functional groups are present in our organic compound, organic material, inorganic material, or the nanocatalyst. The primary use is to identify the water groups. That is, water groups means the what functional groups are the present. That is, if there is a presence of alcohols, or there is presence of the ketones, there is presence of the carboxylic acids, or the any other functional groups. Then second, bond strength and the atom mass. So by using this IR spectroscopy, we can also measure the bond strength and the atom mass also. So these stronger bonds, that is double bond and the single bond. Double bond is stronger than the single bonds, and the lighter atom, that is hydrogen, absorbs at a higher wavelengths more energy. Lighter atom bonds or the stronger bonds absorb at the higher wavelength, means it require the more energy. Then structure confirmation. Then IR spectroscopy helps to confirm the proposed structures and check for the impurities. So these are the three important applications of this IR spectroscopy. There is a functional group identifications, bond strength, and the atom mass, and the structure confirmation. So by using this IR spectroscopy, we can calculate the different types of the functional groups. So this IR spectroscopy, it works with the different principles or the uh, different instrumentation. So they are depending upon this different parts of this instrument. So this every functional group accepts at the different specific wavelength. From this specific wavelength, we get a spectra, and by analyzing this spectra, we can analyze the functional groups with all important informations present in our organic compounds or in our inorganic materials. Next,